Okay, carrying on with the next example. So I've just skipped a little bit because I'm assuming you can do left-hand side, right-hand side for the first term that we prove. And again, making sure everything that we've got in the pink with those headings, right, they are essential. You can't just skip it and leave it and just say, yep, you're done here, and don't actually say, therefore P1 is true. These will just lose you marks in the scheme of things, okay? So assume PK is true. We're going to go back. We're just going to rewrite our original statement, but instead of wherever we see N, we will now have K. That's one of the reasons we love this. It looks like you're doing a whole heap of work, but not really. You're just rewriting stuff and it looks impressive. Okay, so we've just written that. Now we have to prove that PK plus 1 is true using PK. So again, the tip that I've done in every question is make sure that you write, and it sort of just says that's the deal. The whole process here is rewrite PK, okay, lots of Ks, and then the next term, so all of this is PK. Now to get PK plus 1, so the K plus first term, is we replace K with K plus 1. And then we have to do the same thing on the right hand side. So that becomes K plus 1. 2 times K plus 1 is 2K plus 2. Take 1 becomes 2K plus 1. And 2 times K plus 1 is 2K plus 2 plus 1 is 2K plus 3. It's always worth double checking that because that can be the point where you might stuff up. Okay, so let's prove it now. Left-hand side. Everything, right, all up to here, that was PK. So I can replace that with what we said PK equals. That's exactly what I'm going to do. I'm going to say that's K times 2K take 1, 2K plus 1, all over 3. Don't forget, you now have to keep on going. So all of this has been replaced here, but we've still got this K plus first term. And might as well simplify it as we're popping that in. So that becomes 2K plus 2. Take 1, that's 2K plus 1 squared. And before we write our next line, we must, remember, always pop in here. We're doing this using PK. So whenever you substituted in PK, make sure that you pop in using PK. All right, so we want to make this whole line here look like our right-hand side. Always keep looking at what you're going towards. And we can see that we have a denominator of 3, which we don't have here. So let's make it become at least all over 3. So to do that, what do I have to do to make this denominator become 3? Well, I'm going to have to times by 3. What I do to the bottom, I have to do to the top. So this becomes K, 2K take 1, so we're not changing anything for that fraction part. But now we've got 3 lots of, we have to times this by 3. And now it's all over 3. One thing that makes it look like the right-hand side. Always check when you're trying to make something look like the right-hand side. As we said, look at it and look to see, are there any common factors? And we can see right here, we've got a common factor of 2K plus 1 and another common factor here of 2K plus 1. So let's pull that out. If I pull out 2K plus 1, right, from the top, I'm going to put bigger brackets here just so you can sort of see what I'm doing. So I'm pulling this factor out, so I'm now left with K, 2K take 1, and from this term here, I'm pulling out 2K plus 1, so that squared has now gone. So I'm left with plus 3 and just one lot of 2K plus 1, okay? Because when you now expand this times this, you will get that first term, and when you times 2k plus 1 by 3 times 2k plus 1, you will get this 2k plus 1 all squared. Okay, hopefully that makes sense. Now this is going to be all over 3. Again, keep your eye on the right-hand side. We have our common factor of 2k plus 1. What I'm really hoping is that when I tidy up this bracket in here, I'll be left with factors of k plus 1 and 2k plus 3. If I don't, well, then I've got to start looking for an error somewhere. Right, so let's expand that bracket. 2k squared, take k plus 6k plus 3. If you think about the maths, expanding brackets, that's pretty straightforward, but you need to concentrate. So 2k squared plus 5k plus 3. Now, if you're not great at factorizing, you can, have a look at that right-hand side, and it basically tells you what to do, but it's much more satisfying if you just factorize it here. So the only way I can get 2k squared is to say 2k times k. The only factors of 3 are 1 and 3, and because everything's plus, it has to be the plus here, and it has to be the plus 1 there, and that pretty much looks like the right-hand side to me. I was just about to write right-hand side down there. So compare the pair, got the k plus 1, check, I've got the 2k plus 1, check, I've got the 2k plus 3, check. So this doesn't, and I'm dividing by 3, this does indeed look like the right-hand side. Okay, so finish off. Therefore, p k plus 1 is true. And now you have to write your statement. Don't forget to do that.